Hello. Today we're talking about 4.8, which is complex numbers. It's one of the most interesting sections of Algebra 2 because it's something brand new. Most of you have not seen this before, even introduced in Algebra 1. So what I get to do here is tell you what all your previous teachers told you could never do this, and I get to tell you that you can. Okay? So, what is I? I is an imaginary number, and it is the square root of -1. Okay, so we write I when we want to represent the square root of -1. So, when I want to do I squared, that's just saying the square root of -1 squared. So then here you can kind of think of it like the square root and the square are opposites, so they just kind of cancel each other out. Okay, so I squared is just -1. Okay, so I by itself is the square root of -1, but when I have I squared, I get just -1. All right, there's actually a pattern that starts to form, which is kind of cool. So let's explore it, okay? So let's keep multiplying i's together. So we have I times I times I. Well, that's cool, because what happens when I get two of them? Well, that's like I squared, right? Two i's make -1 times I. So I cubed is just -I. Okay, all right, well, that's not really the same thing I've gotten before, right? I told you there was a pattern, so I'm getting I, -1, -I. All right, let's look what I to the fourth is. That's four i's together. And what happens when I have these two and these two? Well, that's just -1 times -1, don't you know? And there we get +1. So if we have two i's, we get -1. If we have four i's, well, then we can see the whole picture. We get 1. All right, so I to the fifth. Well, hopefully now we're starting to see, well, that's just one I times four others. So when I have four of them, that's just 1. And 1 times anything is just itself. So now I have I to the sixth. That's two i's with 4 grouped together. So 2 i's together make -1. And now we're starting to see the pattern emerge. We get I, -1, -I, 1. I, -1, I to the eighth would be 1. So basically, I mean, there is a pattern. It always follows I, -1, I, 1, and then it starts repeating. So it's really important to know that I squared is -1. And if you have I to the fourth, well, that's also good to know because that's just 1. Okay, everything else you can kind of figure it out in between, okay, by doing this breakdown. All right, so that's kind of cool, I think. Cool little pattern. So let's actually practice what happens when I get something other than 1, right? Well, here we can just separate this into two things. This is just -1 times 144. So this is like the square root of -1 times the square root of 144. And the square root of -1 is I, and the square root of 144 is 12. So we're not going to say I times 12 because that sounds silly. We're going to treat I kind of like a variable. So when we talk about it and we manipulate it, think of it like x. So we wouldn't say x12 or x times 12. You would say 12x. So you would say 12I. For B, this is the same thing as saying the square root of -1 times the square root of 7. Well, the square root of -1 is just I, but the square root of 7 doesn't simplify. So we're going to leave the I in front of the radical, okay? We're not going to write it as the square root of 7 times I because it looks like the I is under the radical. So don't do. So don't do this. Sorry, I'm trying to write it out. Okay. Okay, you have to write it as I times the square root of 7. The radical should go at the end. Okay, so let's do part C. So this is the square root of -1 times the square root of 8. Well, hopefully you know that the square root of 8, that simplifies 2 times 2 times 2, right? We know how to simplify our radicals. Okay, I'm really hoping we do. If not, ask me in class. Okay, so here, we always leave our radical at the end, but remember I times 2, we would put the coefficient first. So 2I times the square root of 2. Okay. All right, let's do the last one, part D. So we have the square root of -1 times the square root of 48. So 48 is 2 times 2 times 2 times 2 times 3. 2, 4, 8, 16. Yeah. All right, so we can pull out the 2 pairs of 2. So we end up with 4 square root of 3 times I. So here we get 4I square root of 3. Okay. All right, so now we know how to simplify our square roots. Now let's practice manipulation. Okay, so a complex number is actually all of your numbers. Okay, we used to talk about real numbers, right? A lot of times kids would ask me, why do they ask us to find the real answers? That sounds so stupid. Well, yeah, it sounds silly in Algebra 1 because you don't realize that there's other numbers, right? You have real numbers and you have imaginary numbers. But if we want to talk about every possible number in the whole world, we're going to talk about it like as a complex number. So here you have a real part. Ooh, sorry, went a little close. So this is your real part. And then the BI is your imaginary part. So every number can be written as a complex number. Okay, for instance, 17 is a complex number as 17 plus 0i, right? 4i is a complex number because you can write that as 0 plus 4i. So everything can be written as a complex number, okay? Yeah, hopefully that makes sense. So here we want to, for number 1, we want to add these complex numbers. So here we don't need any parentheses because there's no multiplying. So this is just 3 plus 6i. And then here there's just a 1 out front. So that just makes it plus 4 minus 2i. So now we can combine our real parts and our imaginary parts. The 3 and the 4 make 7. 6i minus 2i make positive 4i. There's your answer. That's all you got to do. All right, here we end up with 5 plus 3i. No multiplying, so we don't need those parentheses. But here we have a -1. So here we have to make sure to distribute. I don't know. Don't forget to distribute the negative to the second one. I get so many people mess that up. So we get -2 minus 4i. We combine our like terms. 5 and the -2 make 3. 3i minus 4i is -1i. Or you can write it as 3 minus I. I don't care. Okay? But it's the same idea. Okay? So now adding and subtracting, you just add and subtract like terms, right? You just combine those as they're said. Now, for multiplying, okay, the product of complex numbers, this, we're going to do it the same way as we've done before. So here, we are going to FOIL, right? 2 sets of parentheses. We're multiplying, might as well. FOIL the 3, then FOIL the 4i. So we distribute the 3 first. We get 15 plus 6i. 4i times 5 is 20i. 4i times 2i, 8i squared. Okay, so then we can start combining like terms. We get 15 plus 26i plus 8i squared. Hold on, I squared is just -1. So I can rewrite that last one as, hold on, let me rewrite that, as -8. Remember, whenever you see two i's together, it's -1. Okay? So now we can combine the 15 and the -8, and we get 7 plus 26i. Let's do number 2. Foil that one out. Foil your 2, foil your 5i. We get 6 minus 4i plus 15i minus 10i squared. So combine those middle terms, we get plus 11i. And then here I have -10, but I squared is -1. So really I have positive 10. So we get 16 plus 11i. All right. Let's do one more, or I'm sorry, 2 more. So practice these, and then I'll work them out. So number 3. Okay, we foil. We get 4 minus 12i plus 12i minus 36i squared. Middle junk goes away, and that ends up becoming a positive, so 4 plus 36, so we get 40. So that's nice. We got rid of all our i's there. Beautiful. Okay. Now, number 4, I can tell you right now, I get majority of people will get this wrong because for some reason they want to do things like this. Oh, that's 9 plus 25i squared. Is that really what that is? Are you sure? Because let's think about it. You're saying if we had just 3 plus 5 squared, that's the same thing as 3 squared plus 5 squared? So 3 plus 5 is 8. So 8 squared is the same thing as 9 plus 25. Oh, no. I hope you realize that that is not true. Okay, so we cannot do that. We cannot distribute the squared because there's addition. Addition and subtraction, we cannot take shortcuts. So we're going to rewrite this problem, right? Hopefully you know that when I square something, that's the same thing as saying multiply it by itself. So do not do this. I get people that do this all the time. Do not take a shortcut. It's got addition. Okay? Take your time. You know what squared means. Write it out. It's not the same as that. Okay? So here we get 9 plus 15i plus 15i plus 25i squared. So we get 9 plus 30i, and this becomes -25. So we get -16 plus 30i. Very different than what you are doing over here. So do not make this, again, I hate telling you guys bad methods, but for some reason I've got to, because I get like half the class wants to do this. Okay? It's like this old algebra trick they think they know. No. Addition. No shortcuts. All right. Hopefully that makes sense. If not, come see me in class.